In this video, we're going to talk about functional groups. And at this point, I think you guys are going to be very comfortable settling in to organic chemistry. Now, we're going to identify the functional groups as we proceed. And essentially, you need to know these, right? So these are just route memorization. And functional groups are important because usually this is a part of the organic molecule that actually reacts. So any sort of reaction that occurs is mostly involves functional groups. So the first functional group that at an undergraduate level you should be able to recognize is, and just for context, this is actually penicillin, right? So an antibiotic, strong antibiotic that could treat any sorts of STI or a bacterial infection, etc. Right? So we're looking at penicillin. Now, anytime you see a six carbon ring with double bonds alternating, this is actually what we call an aromatic. Right? Alright, so this is actually an aromatic hydrocarbon. So that is a functional group. Again, anytime you see a six-membered ring with alternated double bonds, it is an aromatic functional group. Now, there must be 3 double bonds within that six-membered ring. If there's 2, if there's 1, it is not aromatic. Right? So just please be careful. Right? So that's what we call it, aromatic. Sometimes you'll see them refer to it as benzene, but the correct functional group name for it is an aromatic hydrocarbon. Now, anytime you see and this double bonded oxygen by itself is what we refer to as a carbonyl. But anytime you see a double bonded oxygen and adjacent to it we have some sort of nitrogen, it could be a nitrogen with 1 hydrogen on it, or even no hydrogens. This is what we call an amide. And we're going to differentiate it from an amine, which is something different. So again, a carbonyl group or a double bonded oxygen adjacent to a nitrogen, it doesn't matter if the nitrogen has 1 hydrogen on it or 2 or even 1 or none, it's still an amide. Again, just to reiterate our point, as you could see, this double bonded oxygen has a nitrogen adjacent to it. However, this nitrogen doesn't have any hydrogens on it, but it's still an amide, right? And in different videos, the point of this video is not to differentiate between a primary amides or secondary amides. But again, you should just know that anytime you see a double bonded oxygen and adjacent to it, you have a nitrogen. Doesn't matter if it has 1 hydrogen or 2, etc. It's still an amide. Now, if you see a double bonded oxygen adjacent and you have a hydroxy group, or what we call an alcohol group, this is what we actually call a carboxylic acid. So this is a carboxylic acid functional group. Now, anytime you have a sulfur and sandwich in between, you have just any R group. It could be anything. In this case, we have carbons adjacent to the sulfur. This is actually what we call a thioester. For this one, at the undergraduate level, you're rarely going to see thioester unless you're, I don't know, maybe at Stanford or whatever, or Harvard. But at the undergraduate level, thioester is something that you shouldn't worry about. But the carboxylic acid, the amide, and the aromatic ring should be something that you should be very comfortable identifying. Right? Let's try to continue our conversation. So this molecule that we're looking at is dopamine, and it is thought to be deficient in patients with Parkinson's disease. Right? Now, anytime you have a nitrogen, right, there's no carboxyl group beside it, right? This is what we call an amine, right? So notice the difference between, I'm writing amide here, but it's an amine. And notice the difference between an amine and an amide. The amide have to have a carbonyl group or double bonded oxygen adjacent to it. If you just have just a nitrogen and there's no other functional group adjacent to it, this is what we call an amine. Now there's different sorts of amine. There's primary amine, secondary amine, tertiary amines. Again, the point of the video is not to differentiate between those. We're just saying you need to be able to identify whenever you see an amine versus an amide. Okay. Again, we've already spoke about our benzene ring, or in other words, this is our aromatic hydrocarbon. Now, these OH groups in organic chemistry, all right, I'm grouping them together, but again, they're single by themselves. I'm just grouping them together. These are what we call an alcohol. This is the alcohol functional group. Sometimes you'll hear them call it hydroxy, right? Hydroxy group, right? But that is the alcohol functional group. Let's move to a more complicated structure. This structure is actually capsaicin, right? So it's actually responsible for giving, like that fiery taste to chili peppers, right? So this is this molecule. Now, what can we see here? And I'm actually missing out a couple structures, so this is not quite capsaicin yet. I should have an OH group here, and I should have that group, and that completes your molecule. Now, what functional groups can we identify? Again, we've seen our aromatic hydrocarbon, again, with three double bonds inside the ring, a six-membered ring. This is our aromatic hydrocarbon. The next structure that we proceed to, I want you guys to pause the video and then try to identify as much functional groups as possible. Now, we already spoke about an amide, right? So we see a double bonded oxygen, and adjacent to it we have a nitrogen, right? So that is an amide. Notice the difference between an amine and amide, right? A double bonded, right? Anytime we have a double bond in a carbon chain, this functional group is what we call an alkene. I do not have any triple bonds, but a triple bond you will call an alkyne, right? Single bond, even though it's a functional group, we don't really classify it as a single bond groups like any carbon chain, like any long carbon chain like this, is what we call an alkane. But again, it's not really something you want to worry about. You want to know what your alkenes are, and your alkynes will be your triple bonds. Now, we still have about two more functional groups to identify. We see right here that we have an OH group, and that's what we call an alcohol group, or a hydroxyl group. We have one more, and this is anytime you have an oxygen sandwiched in between two carbons or two R groups, this is what we call an ether. So an ether is usually an oxygen sandwiched in between two R groups. Usually the R groups are carbons. So that is what we call an ether. All right. We're going to move down to this structure. This is actually T4. This is thyroxine. T3 is the active form of your thyroid hormones. But again, T4 is the principal thyroid hormone. Identify as much functional group as possible. Okay? Again, we see an OH group by itself, and that's what we classify again as an alcohol or hydroxyl. Again, we see a six-membered ring, three double bonds, and this is what we call our aromatic hydrocarbon. Again, and we see the same ring on this side as well, right? So these two are the same aromatic hydrocarbon. Now we do see an oxygen sandwiched in between two carbons, and you could guess what this is. This is your ether again. Again, we see a double bonded oxygen, and directly adjacent to it we have an alkyl group, and that is our carboxylic acid. Again, the last functional group, we see a nitrogen, and adjacent to it we have a carbon. Again, that's just a nitrogen. Doesn't matter what type of doesn't matter how many hydrogens we have. Again, we classify this as an amine, right, and not an amide. Let's look at this one. This is testosterone, male sex hormone. What functional groups can you identify? Well, we just see that we have an OH by itself, and that is what we call an alcohol, or in other words, hydroxyl functional group. We see a double bonded carbon within the ring, and this again is what we call an alkene. We also see that we have a carbonyl group, or double bonded oxygen, and beside it is actually two carbons, and I'm labeling the two carbons right here, right? And this is actually what we call a ketone, right? So let's stop here to kind of identify, kind of talk about the different groups that involve or double bonded oxygen. So if we have a double bonded oxygen, and let's say this is R prime, this is R double prime, and it's usually in the form of carbons, where R groups are carbons, this is what we denote as a ketone. Now, if you see let's say this is R prime, if you see a double bonded oxygen, and adjacent to it, directly adjacent to it, we have an oxygen, and let's say this is just some arbitrary like R2, this is what we call an ester. If we see an oxygen sandwich in between two R groups, all right, and let's say this is R double prime, this is what we call an ether. Right. Again, we also have say we have an R group, double bonded oxygen close to a nitrogen, and again the nitrogen can be in the form of NH, or NH2. Well, it's not going to be NH2, but NH or just NH2. Again, this is what we classify as an amide. So these are the three structures: the ketone, the ester, and the amide, are some of the most common structures you guys will see being involved with the carbonyl group that you have to differentiate. The last one that's also important is we have some sort of R group, and we have an OH close to it, and this would be your carboxylic acid. Again, at the undergraduate level, you may also see, right, a carbonyl group sandwiched between a sulfur atom, and this one, again, you're not going to likely see this at the undergraduate level, so we're not going to talk about it, but it's there. So again, this video should cover most of the functional groups and you guys have to know these, right? So it's just route memorization. So this video should cover most of the functional groups that you're expected to see, especially in Organic Chemistry 1.